Greetings everybody. This video, now I might break it into two parts, but this video will hopefully explain how to run the simulation for lab 5, which is Hooke's Law, and then show you again how to, obviously one of our main goals is to be able to do our graphing in Excel. So what you'll do is you'll open up the template, and you should be looking at 4 sheets. Right now I'm on sheet 1. Notice sheet 1 has Hooke's Law, springs in parallel, and so does sheet 2. And then you notice sheets 3 and 4 will do springs in series. So 1 and 2 are springs in parallel, and then sheet 3 and sheet 4 are springs in series. And notice that for each sheet I have the force values entered for you. Notice here in sheet 1, the force goes from 0 to 18 in increments of 2. Sheet 2, 0 to 45 in increments of 5. I mean, you get the idea. So I've already set the values of the force for you. And what I've also done is, what we're going to do is we're going to compare the equivalent spring constant that we calculate using the theoretical formula, which is explained on the instructional sheet. Remember, for springs in parallel, the equivalent spring constant, you just add them together. Again, spring 1 has a spring constant K1, spring 2 has a spring constant K2. The equivalent is stated right here. You just add K1 and K2. So we're gonna compare that value to what we get. Remember from the instructions, when you graph the force F versus X, because it's linear, the slope of that graph will give you the spring constant K. So we're going to compare the value that the slope gives us, i.e. the value that we get from Excel, with the value that we get from the theory, i.e. using the formula. And for springs in parallel, the equivalent is given by K1 plus K2. Now the same thing for springs in series. The only difference is, for springs in series, the spring constant, the equivalent spring constant is given by the formula K1, K2 divided by K1 plus K2. Formulas are given on all the sheets. And again, for each sheet, the Excel value for K, that's going to be the slope of the F versus X curve. So pretty straightforward. All right, so what do we do? Well, I wrote this down here. So let's go ahead. Here's the link to the simulation. Let's go ahead and click on that. And again, I might break this video up into 2 or 3 parts to keep the size manageable. Now here it is, Hooke's Law. You've got intro, systems of energy, and energy. We're going to revisit energy when we get to the next unit, which is work, energy, and linear momentum. But for now, we don't need to worry about that right now. Well, here's systems. So we'll click on systems, click twice, and see here you can choose, if you go over here towards the right, you can choose 2 springs in parallel or 2 springs in series. And we might just start in the order with the sheets. Again, remember, sheet 1 and sheet 2 are springs in parallel, then 3 and 4 are springs in series. Let me pause this video just for a second. Okay, so now we've got the simulation started. Okay, and here's the template. Now again, sheets 1 and 2, we want the springs to be in parallel. Now here, K1 and K2, notice in cells E5 and E6. You need to choose the values for K1 and K2, and that's the same in each sheet. I've already got, I guess, sheet 3 they're already filled in, and sheet 4. But you're going to choose your values for K1 and K2. Well, here's the only thing to remember is for sheets 1 and sheets 3. Sheet 1 is the first parallel combo. Sheet 3 is the first series. You want K1 and K2 to be the same. So let me go ahead and I'm going to choose, let me do 290. You want to choose for sheets 1 and sheets 3, you want to choose values of around 300. 280, 290, 300, 310, 320, in that range. It doesn't really matter. Just in sheets 1 and sheets 3, you want the 2K values to be the same. So I'm going to choose and notice the units are already listed. So I'm going to choose 290 Newton meters for, and don't forget, of course, put your name there. So I'm going to go ahead. Now let me go to the simulation and set those 2K values. So I'm going to go to the simulation. And right here, see top spring, which is the purple, bottom, clearly the yellow. What did I say? 290. So let me go up to 290 right there. And you can also adjust it with the up and down arrows. Nothing complicated. You should be getting used to these simulations by now. Now remember, you can choose anywhere in a range, again, for sheets 1 and sheets 3, anywhere, 270, 280, 290, 300, 310, 320, maybe even up to 330. Right around 300. I'm not too particular. It doesn't really matter. But the idea is you want them to be the same. So notice 290 and 290. All right. Now over here in the box of the things you can see, you want to click displacement, definitely equilibrium position, and values. And now what we're going to do, see this box here that says applied force? Well, using this box, see, you can adjust the applied force and see what it is. It's whatever this lever is, it's pulling on the spring. And notice as you increase the applied force, the springs stretch. Well, what you want to do is you're going to set the applied force starting here in this column here. Remember, the values are already filled in for it. You're going to set F, which is in newtons, to 0, 2, 4, up to 18 in increments of 2. For each value of F, you're going to record the distance that the spring stretches, which is X. So for example, let me go up to, and of course 0, 0, when F is 0, X would be 0. That should be filled in on every sheet. Yep. And obviously you're going to set the intercept to be 0 when you create your graph. So let me go ahead, let me go to the simulation. I'm going to set the force. Again, just to where we are so far, 2 springs in parallel. We know the equivalent is given by this equation. KEQ is equal to K1 plus K2. That is going to go there. We go to the simulation. You know the force values to set that you're going to use. Record X for each of these force values. Let me go ahead and show you. I mean, you get the idea. It's not rocket science, but let me go up to 2 newtons. Oops, I went to 3. Excuse me. Now notice right here, it says that X is now 0.003 meters. That's my displacement, see in the green, 0.003 meters. So let me go ahead to the template. I'm going to enter that in, 0.003. And click check or click outside, it doesn't matter. I like to click outside. Now let me go ahead and you get the idea, then you go to 4. And now X is now 0.007. All right, oops, a daisy. Okay, 0.007. Okay, now I'm going to go ahead and pause the video. I mean, you can do it. Now go to 6, 8. So you're going all the way up to 18 in increments of 2. Let me pause the video and get the remaining values. Okay, so what I've done, I've entered in all the force values. Right here, up to 18, X is 0.031 meters. Those values are all entered. Okay, now we have to do 2 things. We have to calculate the equivalent spring constant using the equation, i.e. the value we get from the theory, which is K equivalent equals K1 plus K2. Then we're going to have to create a graph and get the slope. Well, let me go ahead and enter in cell H5. In Excel language, let me enter the equation to calculate the theoretical value of the equivalent spring constant. Now, I simply want to add K1 and K2. So I simply want to add cells E5 and E6. Okay? Well, so remember, we've got to think in the language of Excel. You do equals. I like spaces and parentheses so I can follow my logic. Space, parenthesis, and I just want to add cells E5 and E6. Remember, I want those cell references to be fixed. I don't want to change the fact that it's column E, and I don't want to change the fact that it's then E5 and then E6. So remember $sign. So $E, meaning always stay in column E, then $5, and you'll see that cell gets highlighted. Then I like to do a space, then plus, another space, $E, $6. Another space or two, close parentheses. Very easy to read. Notice when you type in a cell reference, it highlights. Now hit check, and obviously we're going to get 580. It's not rocket science. 290 plus 290. So the equivalent, according to the theory, the equivalent spring constant is 580 newtons per meter, as it should be. Now let's go ahead and get the value that we get from the graph that we create in Excel. Now I've already entered the formula for the percent error formula. That formula is trivial. It's just H5, absolute value, because percent error or percent difference is never negative. It's just a difference between H5 and H6 divided by the accepted value. Oh, that should be H5. H5 is the theory is the accepted value. That's H5. So notice right now there's nothing there, or 100, because right now we don't have anything in cell H6. All right. So let me go ahead, and you should be getting familiar with this by now, but how do we create the graph? Highlight these two columns, including cells C10 and D10. You want the header. Insert, chart right here, this one. Notice it's it's linear. It might not be exactly linear, but that's quite all right. Okay, I'm going to just take this graph and I'm going to drag it over here, and then I'm going to make it a little bit the bigger. You don't want it so big that it takes up all, but the larger the better. Now I'm going to, at this point, I'm going to do one more thing and stop the video and then pick up where I left off. So just to recap, you should all know this by now. You highlight the X and the F columns, including C10 and D10, the headers. Then you go up to Insert, Chart, and XY Scatter. You should get a graph that looks fairly linear. Now I'm going to click on the graph again. Now we'll go to, there should be a layout, chart design, excuse me. And remember, quick layout, I want this first one right here. And then we have to format it in the way that according to my instruction. And these are the standard way to format scientific graphs. Imagine if you were one of my research students and we were going to submit a paper to a conference or to a journal. Well, if we need to include a graph, they have very specific ways that the graph needs to be formatted. They have very certain specifications, and we need to follow them. Well, that's what I'm going to do here. But let me go ahead and save this video, and then we'll pick up with how to format the graph.